In triangle OAB, O to A is the vector A. So let's mark that on. And O to B is the vector B. We're told that P divides O to A in the ratio of 3 to 2. So this part here is 3, this part here is 2. There's 5 parts there in total. Q divides O to B in the ratio 3 to 2. So this part is 3, this part is 2, and again there's 5 parts there in total. We need to show that PQ is parallel to AB. So we need to show that one of them is a multiple of the other one. Let's do the vector AB first of all. So let me mark that onto my diagram. The vector A to B is this. Now that's going to be the same as me going from A to O plus O to B. Now A to O, let me write that down, A to O plus O to B. Now the A to O, this is the same but in the opposite direction of the vector A. So it's going to be minus A. Same size but opposite direction, so minus A. The vector O to B, well that is the same size and the same direction, that is just vector B. So the vector A to B is minus A plus B. Let's now do the vector P to Q. So this is the vector P to Q, which is going to be the same as the vector P to O plus O to Q. Now the vector P to O, that's going to be 3/5 of the vector A, because remember that the A is the whole thing, which was 5 parts. This is only 3 parts, it's 3/5, and it's also in the opposite direction, so it's going to be minus 3/5 A. The O to Q, again, this is going to be 3/5 of the vector B in the same direction, so positive. So we've worked out the vector P to Q, we've worked out the vector A to B. Are they parallel? Are they multiples of one another? So comparing these two vectors very carefully, and yes, they are multiples of one another. I can say that PQ is equal to 3/5 of A to B. This is 3/5 of this. Therefore, they are parallel. And that's part A of the question done. Part B. Given that the length of AB is 10 centimetres, find the length of PQ. Well, we've just said that PQ is 3/5 of AB. If PQ is 3/5 of AB, then its length will be 3/5 of 10, which is 6.